Right, parametric VAR. So the annual return, example, financial application. The annual return on investment is assumed to have a normal distribution, or it should actually say log normal distribution. The expected return is 10% and the volatility or standard deviation is 20%. What is the probability that the annual return will be negative? So in other words, assuming the Z, I've got a normal distribution there with mean of 0, mu of 0, and standard deviation sigma of 1, the standard normal distribution, then I do a transformation to calculate the probability that Z, the distribution, is less than 0, i.e. if it's less than 0, it's negative. Okay, so there's my transformation, gives me a probability, all right? I apply the normal distribution and I'll get a probability factor. Okay, so then I know the probability will be 0. I can apply that to the portfolio to get an understanding of the chance that I've got a negative return. Okay, what that negative return will mean for the value of the portfolio. Okay, that's the important part, because I want to work out my value at risk, not just the probability of getting a negative return is 20%. What does that mean for my portfolio mark to market? That's the number I'm looking for here. Okay. Example 2.
What is the probability that we find a data value of less than 79 if the mean of those returns is 91 and the standard deviation is 12.5? So this is orthodox normal distribution statistics. Okay, so there is my normal curve there, or the and HR departments love to call that the bell curve. Please don't call it that. Why do HR departments talk about that? Because it's when they do your end of your appraisal, often HR departments have to fit all the output into this normal curve. So if I had a team of 10 people and they were all stars, then I couldn't all give them 5 out of 5. I'd have to give some part of them less because I've got to follow this curve. You can imagine what I think of that, but that's HR departments. Respect to them, let them carry on with their discipline, we'll carry on with ours.
What is the probability that we find a data value of less than 79 if the mean is 91 and the standard deviation is 12.5? Okay, that's fine because I've got a standard normal distribution to look up. Okay, so I will just standardize it. I will apply that distribution to those parameters. So therefore, I've got mean of 91 and sigma of 12.5. Okay, so the Z number, as you see there, is minus 0.96. Okay, the probability is to the left of the mean is 0.5. So therefore, I've got a value of less than 79. If the mean is 91, as you can see in the calculation, 0.1685. That's a probability number. Okay, so then I take that probability and I apply it to the value of the asset to get an understanding of the value at risk. Now, with this being statistics, I need to apply a confidence level. Okay, the confidence level of an interval estimate is the probability the interval estimate will contain the parameters. In other words, it being statistics, I have to know to a certain degree of confidence that my estimate will be in that range. The higher the degree of confidence, the bigger the number has to be. Do you understand the logic of that? If I'm just estimating the value at risk at a 50% confidence, then the value at risk could be a very small number. But I'm only expecting that 1 times out of 2 it'll actually be at that number. Whereas on the other hand, if I want a 99% confidence, the number will have to be much bigger to make sure that it's always capturing what the actual value at risk is. Okay, so you just end up with a wider range, the higher level of confidence. Okay, generally we can write. So in the applications in banking, the most commonly used, the regulated ones are 95% and 99%. Okay, parametric. So read Z sub alpha over 2 is using the general formula for confidence interval. Alpha represents the total area in both tails of the standard normal distribution curve. Alpha over 2 represents one of the tails. Now remember, we're actually only interested in the left side of the tail because we're interested in negative returns. Okay, so we insert that as drawn to understand what's on the left side, what's on the left hand tail, what the probability is of the return being in the left hand of the